Okay, so first off the bat, we'll talk about multiplying polynomials. We've done a little bit of adding, a little bit of subtracting. So next, of course, in line would be the multiplying of polynomials. Just kind of work our way up, start small and then work our way up, so to speak. Yeah, if I have a monomial, one term, polynomial times a monomial, we've already done that. We did this in previous section. That's just, combining what we can combine. We can, of course, multiply the 8 and the 7, 8 and the 9 and get 72. We can multiply the k's, and of course the one rule, the big rule here on multiplying polynomials is when we multiply polynomials with the same base, we add the exponent. So that one will be used quite a lot here. So we get k to the 5th, right? And then what about the y's? It'll be y to the 6th because, yeah, there's an understood 1 power there. So we add those two together. So we've done that. Well, if we bump it up to, say, a monomial, 7x squared, times a binomial, of course, we've encountered something to this effect before, more or less. Wasn't quite as complicated, but we have done this, and what's the word for that? Distribute, okay? Yeah. When you have a monomial times a binomial or beyond, bigger, yeah, it's distribute. You got to multiply that 7x squared by everything in the parentheses. So yeah, no big deal. That's what, 21, 7 times 3, x. Of course, then you got x squared and x. It's to add the exponent rule again, the x cubed, and then of course times 4 would just be 28x squared, and 7x squared times the 4. Okay, yeah. So that's what we do if we had that. Now, what would this come out? Say we had negative 2r times 3r squared plus 9r minus 5. Same story, isn't it? Yeah, if you have a monomial and it's going to be multiplied by binomial, trinomial, 4 terms, whatever, that has to be distributed. That 2r is going to be inside, multiplied the inside there. So what do we get? Negative 2r times 3r squared is negative 6r to the 3rd. Negative 2r times 9r, well, negative 2 times 9 is negative 18, and r times r is r squared. It's r to the 1st, so we're adding 1 and 1. And then negative 2r times negative 5, well, that would be a negative times a negative is positive, 10r. 2 times 5 and r. Okay? All right. So yeah, that's pretty well what we've done in the past. It's just really a little more as far as the powers go. All right, so we did monomial, 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 binomial, monomial, and bigger. Well, now we need to think multiply 2 binomials. Try that out. Well, some of you may already have this figured out, but if you haven't, that's okay too. We'll talk about it here. So yeah, we've got binomials. The deal is each of those things has to be multiplied by the one and the other, parentheses. other words, the x has to be multiplied by the x and the 8. The 5 has to be multiplied by the x and the 8. It's the same idea as the distributing there, but we do have a binomial to distribute, basically. Now, the way typically we remember this or state what we need to do here is by a little acronym known as FOIL. Heard of that? A little bit, huh? Okay. Standing for multiply the first, outer, inner or inside, and last. Yeah, there's going to be 4 products, if you will, that we need. The first, the outer, the inner, and the last. So that's goes like this. The first, the F, is the x times the x. X times the x. Of course, that's x to the first, so that's x squared, isn't it? Then we have to multiply, do the outers, meaning the outer 2 on the parentheses there. So that's x times 8. That's usually, we say 8x, don't we? Positive 8x. The inner, then, is the opposite of those, the inside-most 2. So that's 5 times x. Multiply those 2 together, so that's plus 5x. Each of these is a different term. So the 5x, positive 5x, and then the last, well, that'd be 5 times 8, which is 40. Yeah. So it's just, FOIL is just a nice little way to remember, hey, yeah, I've got a lot there to multiply than I might think originally. Okay, so that's our result. Now, of course, what we have to watch for is, like we have in this case, yeah, we're talking 4 terms, and if we have like terms, do need to simplify those, right? Combine the like terms if you can. Sometimes maybe not any 2 combined, but in this case I do have in the middle the like terms of 8x and 5x, same variable with power. Yeah, so add their coefficients. Variable stays the same when we add the like terms, because we're not multiplying there, we're just adding them. So the variable doesn't change in that case, right? So we wind up with a trinomial, which usually happens a lot when you FOIL 2 binomials. All right. Well, just go through a couple of other cases, 2 binomials. 4y minus, let's do k. 4y minus k times 2y plus 3k. See what we get when we FOIL that out. Now, of course, this one has the extra part to it. We have 2 variables. That's no big thing. Just take care of it as keep up with the variables and all that. So what do we got? FOIL, so we do the 4y times the 2y. That would be 8y squared, as we are multiplying. 4y times 3k is a 12. And let's just write it as yk. Then we have the minus k times the 2y, so it would be minus 2yk, wouldn't it? And then minus k times 3k is minus 3. And we've got k to the first, so that's k squared. Okay? And then again, it does happen. We do have like terms in the middle, so combine those. 8y squared then would be plus 12, and minus 2 is 10, positive yk. And then bring down the minus 3k squared. All right? Now, should be pointed out, a couple other things can happen when you multiply binomials. One thing else that could happen, well, if you get, let's say you had 2x squared plus 3 times x minus 9. In that case, if we FOIL that out, 2x squared times x is 2x cubed. 2x squared times minus 9 is minus 18x squared. 3 times x is positive 3x. And then 3 times minus 9 is minus 27. And if we go to look to see what we can combine there, what can we combine there? Nothing at all. All right. So not always will we be combining the middle terms, but it happens a lot. But it won't always. In that case, nothing combines there. And then something else can happen if we have, say, 5x minus 4y times 5x plus 4y. Something a little bit opposite of that happens there, because 5x times 5x is 25x squared. And then 5x times 4y is 20xy, positive. Then I have minus 4y times 5x. What about that? That's minus 20xy, or yx. And then minus 4y times positive 4y is minus 16y squared. Well, it just so happens in this case, what happens? We have a cancel. Yeah. We've got a positive 20xy and a minus 20xy. 20 minus 20, that's 0 xy. But is there any need to write 0 xy? No, there isn't. 0 times anything is 0. So, yeah, those just effectively go out. And we wind up with just a two-term product there. So that can happen as well. Okay? All right. Now, I want to talk about next squaring a binomial. But let me first of all, well, let's just go ahead and talk about it. Squaring a binomial. Different ways you can do it, but what I recommend doing when you have a binomial that you need to square is this. 2m plus 5, and we want to square that. Well, the deal is, unfortunately, this one doesn't quite work as nicely as, say, if I was just having to square, say, 5x to the third squared. There I can just say, well, it's 5 squared and x cubed squared. I can just do, what, 25x to the sixth, multiply the power. Now, the reason this is different is because if we think about this, and this is how I recommend doing it, what that means is 2m plus 5 twice, right? 2m plus 5 squared means 2m plus 5 twice. And the reason I like to do it that way is because that highlights why we can't do it like this, where I square that and square that, because if I write it twice, that's a binomial, two binomials multiplied together, isn't it? And when we have two binomials multiplied together, what is it we have to do? FOIL, yes. There's a FOIL thing involved here. This one, there's no FOIL. Here, yeah, that, if we write it twice, hopefully, helps you remember, it's got to be FOILed out. There's more terms than just the two terms being squared out. Yeah, so this is, write it out twice and FOIL. That's what I recommend, squaring a binomial. So you have 2m times 2m is 4m squared. 2m times 5 is 10m. 5 times 2m is 10m. And 5 times 5 is 25. So that's 4m squared. Middle terms are 20m, 10 and 10, plus 25. Yeah, so if I just squared that and squared that, I just get 4m squared plus 25. I'd leave out a whole term there that's in there. So it would be inaccurate if I just did just square the two. So that's what I would recommend on squaring a binomial. All right, now what happens here? What if I had 3x minus 4 squared? Well, very same idea. Squaring a binomial, so write it twice and FOIL it. Because that's what 3x minus 4 squared means. 2 copies of 3x minus 4. All right, so that's 3x and 3x is 9x squared. 3x and minus 4 is minus 12x. Minus 4 and 3x is minus 12x. And minus 4 and minus 4 is plus 16. And the 2 in the middle give me 9x squared minus 24x plus 16. Is this okay? All right. A couple other products here. Let me go ahead and mention. What if I had this, 2k times 4k plus 1, but then I had another pair of parentheses and it had 3k minus 2. Well, of course that's three things multiplied together. I've got 3 things here I've got to multiply together. Well, I do have to at some point multiply everything all together, and there's different orders you can approach this. Here's one way. Yeah, since we've got the binomials here, maybe a little simpler if we do those first. Keeps the, well, it'll be about the same either way, but yeah, you could do the 2 binomials FOILed out first. The other thing we could do is go ahead and distribute the 2k, do these 2 first. You could do that. Different orders you could take, but my recommendation, let's FOIL those 2 out first. FOIL these out, and then we'll distribute our 2k. Okay? So we FOIL those 2 out, that'll be 12k squared. 4k and minus 2 is minus 8k. 1 times 3k is 3k positive. And then 1 times minus 2 is minus 2. So we'll have 2k times parentheses 12k squared. Middle 2 are like terms, so we can combine them to minus 5k. And then minus 2. Yeah. So the FOIL there gives me that. Then, last but not least, distribute. Distribute your 2k. 2k times 12, k squared would be 24, k to the third, wouldn't it? And then 2k times minus 5k is minus 10k squared. K to the first, k squared. And then 2k times minus 2, minus 4k. All right. Okay, so there you have it. That's another thing we might encounter. Now, the other one I was going to mention is one where it's not exactly FOIL, but it's an extended version of FOIL. Let's say I have 2a minus 5 times 5a squared minus 6a plus 2. Not exactly FOIL, is it? Because FOIL is 2 binomials. This is a binomial times a trinomial, but it's FOIL extended, let's call it, because it's the same idea. On your FOIL, like over here, you're multiplying the 4k times these 2, and then you're changing around and you're multiplying the 1 by those 2. That's what FOIL is. Well, same thing can be said here. What I need to do first of all, right, is 2a times the 3 over there. So I'm going to take the 2a times the 3 over there first of all, and then do the same thing for the minus 5. So that's that's going to be 6, isn't it? 2a times the 3 and then minus 5 times. So we're going to have 6 terms. Then we'll collect the like terms. All right, so let's do that. 2a times 5a squared is 10a cubed. 2a times minus 6a minus 12a squared. And then 2a times 2 is plus 4a. All right, so then I reboot here and do the same thing with the minus 5. Minus 5 times all 3 of those over there. Minus 5 times 5a squared is minus 25a squared. And then minus 5 times minus 6a is a positive 30a, because you have a minus times a minus. And then a minus 5 times 2. Yes, minus 10. And as happens a lot, there are some like terms, aren't there? What do I have like terms wise? Anything like the 10a cubed? No, because it's got to have a cubed on it, doesn't it? Nothing a cubed over there. However, I do have a minus 12a squared and a minus 25a squared. Got like terms there, don't I? Minus 12 minus 25 is minus 37a squared. And then I have 4a and a 30a. Those are like terms, aren't they? 4 and 30 is 34a. And then minus 10, well, nothing like it. So there you go. Okay? This sound okay? All right, so that's multiplying of some polynomials.